Are you interested in learning how electricity works? You've come to the right place then. In this video, we're gonna talk about everything electricity. So sit back, grab some coffee, and get ready for this ride. What up, everybody, and welcome back to another show of Inspector Digest with your certified home inspector, Andy G. In today's episode, we'll go over information to try to understand how electricity works. Electrical supply is basically the movement of electrons that flow along a conductor, like water flows through a pipe. Yeah? It's safe to say that the bigger the pipe, the more the flow. This is the principle behind resistance. An analogy to understand electricity can be a water pipe where the voltage is the water pressure, the current is the flow, and the resistance is the size of the pipe. Current is equal to voltage divided by resistance. Alright, so current equals flow rate, amp equals I. Voltage equals pressure, volts equal E. Resistance equals pipe size in this example, and ohms equals R. So let's see how this relation applies to plumbing systems. Assume you have pressurized water coming out of a garden hose. When you increase the pressure, more water comes out of the hose. Same goes for the electrical system. When you increase the voltage, the current increases. Now, assume you increase the diameter size of the garden hose. More water will come out of the hose. Similarly, when you increase the resistance of an electrical system, the current flow increases. Did you get it so far? All right. Let's talk electrical power. The power of electricity is measured in watts. Power, or watts, is W, which is equal to the voltage, which is V, multiplied by the current, which is I. To understand the power, think of taking the water pipe and pointing it at the top of a water well. To increase the power generated by the water well, you can A, increase the pressure of the water coming out of the pipe, or B, the flow rate of the water. Now, let's move on to measuring electrical forces. When discussing electrical supply, we use many different terms to quantify the amount of available power, the amount of work it can do, and the resistance of the components, and therefore its safe operating parameters. Here are some easy to understand definitions and explanations of the terminology. Let's start with resistance. Resistance is the limit that conductors have the ability to allow the flow of electrons, just as friction causes losses in any pipe or ductwork. This is expressed as ohms. Another important term when discussing electrical supply is electromotive force. Electromotive force is what drives electrons along the conductor and is expressed as voltage or volts. Current is the flow of electrons driven by the electromotive force through a given resistance. This is expressed as amps. Lastly, power is the amount of work that the electrical flow can do. This is expressed as watts or kilowatts, which would be 1,000 watts. In order to understand electrical supply, you must first have an understanding of what Ohm's law is. George Simon Ohm was a German physicist who started his research when the then recently invented electric cell led by Alessandro Volta. Now, Alessandro Volta was an Italian physicist who invented the electric battery, which provides the first source of continuous current like the one in your car. You feel me? Ohm determined that the current that flows through a wire is proportional to its cross-sectional area and inversely proportional to its length. Using the results of his experiments, Ohm was able to define the fundamental relationship between voltage, current, and resistance. He's like the godfather of electrical circuit analysis. Ohm's law are a series of mathematical models that show us how to work out safe working loads for conductors and electrical components. This allows us to understand why a 30 amp fuse should not be connected to a 14 American wire gauge, which is AWG. Because it's about resistance and overheating wires, so it was like a control limit. Now, Ohm's law defines the relationship between voltage, current, and resistance. Where I, again, we spoke about that, is the current measured by amperes, which is amps, A. R is the resistance measured in ohms, which is E is the electrical potential voltage, and W is the power measured in watts. I know that's confusing, but don't worry, we're gonna wrap that all up so you understand. Now, watts equals volts times amps, or W equals E times I. This is important, especially if you're trying to become a home inspector or you're an electrical contractor or worker and you want to understand more on exactly how this whole process goes about. You have to know these formulas, these breakdowns. So another would be amps, which equals watts divided by volts, or I equals W and E, okay? Amps measure current, okay, which is the value of the current, which again is the number of electrons flowing past any given point per second, which is measured in amperes or amps, okay? Volts measure pressure. Electricity arrives at a household circuits at a pressure of 120 or 240. Watts measure power, and you could compute wattage by multiplying amperage and volts. Let's look at an example of that. Assume an electrical clothes dryer is using 240 volts and it's rated at 7200 watts, which pulls 30 amps. That would be 7200 divided by 240 would be 30. This means that the dryer must be protected by a 30 amp circuit breaker. You get that, right? And the wire carrying the current to it must be a number 10 copper, which is rated for 30 amps. It's important to understand conductor sizes, material, ampacity, and the limitation of conductors. As we saw with Ohm law, resistance is key to a conductor's ability to safely deliver the amount of power that a circuit needs. Think back to the pipe. The bigger the pipe, the lower the resistance. When evaluating electrical supply, we need to recognize that copper and aluminum conductors are not the same. Although they are both commonly used, copper inherently has less resistance on the flow of electrons than aluminum does. As we have seen, for larger amperages, we need larger conductors. Here's a guide to amperage capacity and uses of common conductors in residential constructions. For example, 15 amp breaker can control lighting circuits and typical general use receptacles. And a 30 amp breaker can power small AC units and clothes dryers like we spoke about earlier. For those of you who wanted right now information to understand basics on how it is that electricity works, I think this video would be suffice. Now, I'll make sure to include in a follow-up video in more detail how residential electricity works. And that will speak about how it comes into the house, what a service drop is, or overhang, the panels, etc. And hopefully be able to educate and produce more knowledge to those of you out there who really want to become one with the home that you live in. All right, thank you everybody. Once again, this is Inspector Digest, Andy G. You already know, hit like, hit subscribe, hit comment, hit that bell so you get fresh information every time we let it out. Thank you so much. Goodbye.